Well, so in this semester, you have registered some of the very important courses. And yesterday also we discussed a lot about the origin and the various pathways, the so-called the communication systems, how far they developed, and historical perspectives, and various applications. All the way we have searched. And electromagnetic field theory is one of the most important fundamental concepts of all. So it is the origin for circuit theory, it is the origin for communication theory, as well as electronics and many other aspects, even quantum mechanics and many other advanced topics as well. So it is very essential. In fact, to every engineer, of course, almost everyone supposed to learn about this course. And today we are going to discuss about the mathematics of the course. That is, what are the mathematical aspects involved in that. So before that, I would like to give some idea about what are the opportunities, particularly job opportunities available in the field of electromagnetics. So this electromagnetics, the moment you just think you should think about the electromagnetic field. So it is anybody can easily understand this particular one. So I believe you can easily recognize the electric and magnetic field which is traveling in a particular time. So both are transverse each other, which means both are perpendicular to the direction which is traveling. So this is the electric field and a magnetic field will be there. So both are actually uh, going like a sinusoidal wave, something like that, maybe in phase, maybe out of phase. So when this wave is traveling, immediately it can change it will change its property with respect to the medium, and medium will change its property with respect to that. So if if this signal changes its property, let's say its amplitude is E naught, and it is going to be another value like E naught dash. When this E naught dash is less than E naught, then we call this as attenuation. So that is the very common term we use to say that the signal lost its power. So that is called attenuation. When the value is greater than that, it gained. So it is nothing but a gain. And the same similar property can be applicable to the medium as well. The medium will react and will change its property. So we know that the medium is defined by the permittivity and the permeability. So these two produce a new idea called wave impedance. We will study all these things. So here comes the very important term called impedance in the way. So this impedance will react to this. So the most common method to connect this electric magnetic field and wave impedance is that the electric field by magnetic field is nothing but wave impedance like that. So clearly we can see that how this electromagnetic wave is converted by the medium and also changing the medium's property as well. So both are highly interrelated. So this particular fundamental aspect, if you if you take this to various aspects, let's say if you take a parallel plate and when an electromagnetic wave is traveling inside that, how this is going to behave. So there will be a coupling of these two plates by means of electric field will come. That is often evaluated by a coefficient capacitance. Similarly, multiple turns will give inductance, and both of them, when it is connected to each other, you will get LC parallel. This LC parallel, which is storing electric field and magnetic field, at one particular frequency, they will be having equal magnitude. So the energy stored by the capacitor as an electric field and magnetic field stored as the energy in form of inductance. So both will be sometimes equal, and that is what we call resonance. This resonance you can see in multiple features of the physics. So this resonance and this particular property, when this frequency is very, very high, which we call resonant frequency, which is often referred simply by 2 pi root LC. If this frequency is in gigahertz, if it is in megahertz, we call that as a radio frequency. If it is in gigahertz, we call that as a microwave frequencies, terahertz. Then high frequencies, much more faster than that. So this this particular aspects of electric and magnetic field, which is giving this behavior, then ultimately this is giving a very important phenomena. By changing this inductance and capacitance, we can vary this. Therefore, the concept of tunability is coming into the picture, and that is the very first behavior in the field of uh, this electromagnetic field theory, very first applications out of it. If you take an antenna and you just take a LC like this, and it is tunable one. Both are tunable one. When you tune that, it will be tuned for a particular frequency. So except a particular frequency, remaining all frequency will be sent by. So there comes the demodulator, all these things will come. So this is going to behave like a filter, and this filter will uh, allow only certain range of frequencies. And so you will be sent, it means with respect to frequency, your signal may be having so much of power, but you want only in this range, only within this frequency range. So this filter will allow that, and remaining noises, everything will be cancelled out. And that is a very simple application in the field of radio. And there comes all the tunability, everything into the picture. We will discuss about this concept much more in detail, much more in more mathematical manner. But this is a very, very simple definitions out of that. So this is, we can say that by understanding this, one can design so many important circuits. So that is often referred as RF and microengineering. So the RF and microengineering is nothing but development of high frequency circuits for many applications like communication, microwave, microwave ovens. Then that is all coming under microwave control units. Like nowadays, remote controls are coming into the high frequencies, Bluetooth, then Wi-Fi, and then in future you will be getting interchip communications between in the, because at very high frequencies, these wires, they just behave like a lossy element. So wireless will be good choice in that case. Then satellites, and then in satellite itself we can find substations. So between the satellite to satellite communication. Then of course in defense it is greatly used as a radar and many other aspects. So for this all we need a huge number of manpower, and they often referred as RF and microengineer. And in future so many aspects also going to, particularly in the 5G deployment and terahertz electronics, we have so many requirements in that regard. So what you see here in the right hand side is nothing but a RF module, RF and microwave module. This is actually a 77 gigahertz transmitter, and the receiving, this is nothing but a automobile radar. So it has a oscillator, then doubler, amplifier, then power amplifier, then at the receiving side, low noise amplifier, then mixture. These all, whatever that you see, they are all directly going to convert the signals and going to detect that when it is received. So this all will be operating straight away in the 77 gigahertz. So at 77 gigahertz, how these electronic circuits are going to, how they are going to operate, how to control their behaviors, how to synchronize them. So you can see here some amount of signal is tapped and compared at the end. So this simple circuit, this is going to be a simple chip. For this, so many companies now they have opened so many opportunities. That is why even actually I'm also learning how to construct these simple systems. Actually, in my case, I know voltage controlled oscillator and high power amplifiers, which I am now working on. Then mixers, we are having some team, they can successfully work on that. And I know about low noise amplifier. So, and our group also working in antennas. So by means of having this within about size of 1 rupee coin, we can make this system very easily. And if it is made in the form of integrated circuit, which we call chip, on a silicon or gallium nitride substrate. Then we will get IC. You are calling so many ICs like Qualcomm, in MIGTech, and Samsung, like that. Actually, they are having their own chipsets. So these chipsets are having this very few modules, but they will be having reconfigurable modules. Like you can even plug in something else into that, and you can connect. You can install new softwares in that. Such a very reconfigurable module. So for those kind of works, we need this RF engineers. So, and interestingly, this RF engineer job is only applicable to ECE students. In fact, no other engineering discipline cannot even enter into that. That is a specialty in this. So if you check the recent salaries, this is actually today morning I checked the salaries of the RF engineer in US. In US, actually, we have so many opportunities. In India, we have, but in India, we have only design level. Very few companies like Samsung, and then Cree, and then Philips, and then Will Street, like that. Actually, very few companies they have evolved as of now in the RF side. But you, as I already mentioned, you have to open like a uh, so-called what the world citizen. So you have to simply should not think as an Indian or something like that. Always you have to think big, particularly as in the size of world. So when you think that the opportunity is wide open and you can see the salary, may I know what is the current uh, currency of, means the currency exchange rate in dollar, $1? Can someone say that?
74 rupees, sir.
Okay, 74 rupees. Can you multiply this with 74 rupees and can you tell how much approximately will come? Closely, I think 7. This is already 1,30,000. So it should come closely around
10 to 1 2 000.
can you say in rupees? Something like that. No, this is already 70 lakhs. Okay. Then 30.3 into 721 will come. So another 20, nearly about 90 lakhs, I think will come. So 90 lakh divided by 12, you can calculate yourself that how much.
So almost 1 crore. So almost 1 crore.
Yeah. So you can easily become crorepati in a year. But of course, this price, this actually to reach this level, it takes minimum 5 years. And this the average also, it is really good number. And we could say that it is in the first 1 or 2 year itself, you can reach say, a good some amount of salary. For this, what are the things you have to do? We will discuss maybe in the next 2-3 slides will come. And another very common engineer is applications in electromagnetics is radiation systems. That is nothing but antenna design engineer. This also nowadays it is evolving much more faster way for the same set of applications. I already mentioned that there is an antenna requirement for all type of frequencies, and it depends on the various applications. For example, you know about dish antenna, how the look like. It is particularly meant to send the signal and the receive signal in a particular range of frequencies. Maybe it's the angle requirement is 5 degree or 10 degree within that. But if you see the mobile phone antenna, it's supposed to receive the signal and transmit the signal in all directions. So different types of antennas required. So there is a huge number of antenna system requirements. You can see that this Apple's uh, lab, which is about, I think in Indian money, this is closely about 100 crore worth lab. And this is actually one of the lab like that. They have around 7 labs. So this is the lab where they will set the mobile phone here. The person will come out of that. And in so many places, you can find receiving system. So when this mobile is turned on, how this is going to radiate around that. And by efficiently making it, one can even make powerful systems like with even very low power itself, your mobile phone can receive the signal. So what is the advantage of that? Assume that you have a tower which is nearly about 60 feet and we are about 6 feet or maximum. our mobile phone is here. So this is the direct signal will come. So if I send about 100 watt power, here it may come around some 10 milliwatt power will come. Okay, so now I have improved my antenna system. It can receive 10 times more power. So it will receive now 100 milliwatt power. So by the way, I can cut down and I can send only 10 watt power. 10 watt power, 100 watt power. This is the amplifier gain supposed to increase by 10 dB, which means 10 times the power has to increase a lot. So for this, actually, the running cost will be in a year, at least one tower will be consuming around some 4 to 5 lakhs rupees. Even I'm telling very less amount. In terms of electric bill itself, I'm saying that because there is a separate running AC will be there, so many things, and even noise cancellation, so many aspects are there. So developing 100 watt transmitter is very tough job. Only about 7 to 8 companies are there. Can you tell any one of you heard about any mobile tower design company? Any? I think the very first company who developed such an idea is Nokia. Then Ericsson also joined. So Sony Ericsson become one of the famous mobile phone, I hope you're. And other than that, we have Alcatel. Then recently this Redmi also started that. So many things are available. And there also pay scale is very huge. You can see that it is as good as the RF engineer. So of course, for this, you have to work around at least minimum 5 to 6 years of experience is required in the field of antenna as an industrialist or something like that. Another very important one is Emi Emc Engineer. So these engineers, they will evaluate the consumer electronics, radiation ability, particularly every system supposed to be certified by the EMI, what do you call, compliances. So for this, there will be sophisticated measurement tools will be there. Using that, they will certify the, for example, you heard about that like SAR rating. So that is telling about how much heating the microwaves can do on the human body, on the ear, on the brain, on the hands, like that. So these kind of evaluation will be done by RF engineer. And this also one of the very interesting study. This study can be very useful in the defense application. Very recently, as I already mentioned, that electronic war is going to come in future. So they will destroy the electronics only. And in space technology also, it is highly recommended because in space, so many noises are coming. So we have to reduce that. So these three, what I found, which is very important. Other than that, so many jobs are available. Particularly this RF engineer jobs, now it is open inside the semiconductor industry also. We know that, may I know that anyone knows what is the recent speed of microprocessor, this four or octa-core processors? You hear some frequencies in gigahertz. Can you tell the value of this? For example, you may be having some laptop and which is operating at this particular frequency like that. You may hear about FinFET. So,
Sir, I guess it's 1 to 3 in the range of 1 to 3.
yes. Now the maximum is 4.1 gigahertz. Okay.
Yes.
So this maximum 4.1 gigahertz is already in the range of microwave. Microwave frequency is more than 3 gigahertz or greater than that. Up to 300 gigahertz it is so. So in fact, the original intrinsic this chip can operate at around some 12 gigahertz due to many things like parasitics and delay lines. So many things are there. Because of that, somehow they have optimized to 4.1 gigahertz. And this is already in gigahertz. So, or whatever that is applicable in the RF and microwave system. Now, this chip is simply nothing but RF system only. Okay, and all the digital signals, there are so many. What do we often now people are complaining about the dispersion property, like the pulse, which is like this, which will be dispersed like this. And when it is coming out of the chip, it will be dispersed like this, which we call actually pulse dispersion. So due to that, it is changing the entire property itself. So this is all. So now if you see that Intel is now recruiting RF engineers. So in fact, one of my friend who works in the field of VLSI, he called me and asked, actually, may I know the reason that why this Intel is recruiting now RF engineers? Because he know that I am RF engineer. So he always asks this kind of curious questions. So the simple answer is this, that they now start to get the problems, particularly the bus, which we call the wires which are taking the signals. They are very close by. At this particular frequency, they couple each other. So the bit 1 may go to this line, which is supposed to carry 0. It may go 1, and 0 information will be exchanged. So always noise sometimes may come. So now we have to solve these problems. So how to do that? There are interesting electronic circuits needed in the future. This jobs will be very interesting, and at the same time, definitely it will be challenging ones. So what are the things you're supposed to be good at in this case? Like you're supposed to be good at circuit theory, and for this, and then simulation of that. And simulation means not only simply multisim or something. There are some advanced tools like ADS. Maybe I will teach if possible. And then microwave office, like that tools are available. So they can solve all the fundamental circuit theory problems as well as RF and microwave systems. So we are utilizing these two tools to develop many amplifiers, oscillators, and development of them. And if possible, if you have good knowledge in hardware design, that is well and good. So then RF and microwave system design, it's a separate topic. So that also should be good at. And you should be good at the measurements. Since the hardware design is coming to the picture, measurements are very, very important. And likely this EM tools supposed to be learned, like HFSS, CST Studio, all these things. I think of teaching this HFSS in this semester for you. In 1 or 2 class itself, you can easily get that idea. Then thereafter, you can start to construct some of the simple electromagnetic systems and microwave systems in that. And then once you have pioneered, then you can even think about the jobs on that side. I always check the skills required for the Starlink. I think all of you know about that. The SpaceX, one of the very important project is nothing but Starlink. So they are actually, this is today's web page. So they are expecting RF engineer. You can see the list of requirements what they have mentioned, and they want only BTech students in that regard, not even MTech or PhD fellows. I think there will be so many jobs. If you simply go to SpaceX, I think around some 700 jobs are there, it seems like. So you can imagine about how big the company is and what type of works. And this not only applicable to this, and like SpaceX, we have Facebook also now recruiting RF engineers. I do not know why, but there will be, I think, a hidden agenda might be there in far future. They may be deploying their own mobile phones or something like that. So now the demand for the RF engineer is huge. So I always keenly look at the requirements of this. In fact, the very first advertisement of the SpaceX RF engineer, I still have it in my room. I have taken the printout of that, and so there actually very similar wordings will be there. There extra this HFSS, then ADS or microwave office will be required, like that it will be mentioned. So how to explore this? The very simple idea is, now you are in second year or third year. So, and your final year project is just 1 or 2 years away. And you can think about that. That decides what you want to be. And accordingly, you can shape your your learnings. What are the things you're supposed to learn? This is only one field in the EC. You have image processing, such a very interesting topic. Then VLSI engineering is there, embedded system is there. So for whatever it is, you can start to think about that as soon as possible. And I am a kind of a helper in that regard. So if someone asks me, then I will understand the problem, what they have in mind. Then I will direct them to the right professors and making the link. And those people I found really successful. Those who have started to think about their final year projects in second year and third year. They're really successful. Recently, what is the one interesting thing happened? The student who studied with me in the first year for the semiconductor devices, he is always very curious about the this gravity, and he himself work on the gravitational problems. He derived microgravities like that. For example, inside the sun, how it looked like there is something like microgravity. Macrogravity is, of course, all of you know about that, like black holes and all these things. So I was also curious about that. So in a one class, I told about this how one can get that quantum data inside the black hole like that. When we started the discussion, he immediately jumped into that, and in fact, he was so interested in that. And but he told after that he supposed to do masters in gravitational problems like that. But what project I supposed to take like that, he asked me. Then I said, yeah, it is very, very simple. You can go for a radio telescope, like optical telescope. We can receive the radio signals from many of the things, and particularly from the sun or moon, you can read out of that. So he worked for about from third year end to final year end. That is around 1 year he spent time, and he successfully demonstrated RF yes, radio frequency means radio telescope. And this is supported by two important universities. One is IIC Bangalore and IIT Bombay. So they worked in various aspects in measurements, only just for the students' curiosity. So you can also do very similar things like that. If possible, I will ask him to give some small lectures on that topic, how that can be done all the way. So many opportunities are there. So you have to do only thing. You have to pay attention to what is happening around the world. Just and in case of any doubts, you can also ask me through WhatsApp or Teams. I'm ready to help. Okay. So there's all the opportunities I could say, but on the way, so many things we can learn. Now we will go into the course that this electromagnetic field theory and the transfer line theory, which is a highly mathematical aspects are available, and particularly this vector coordinate system operators. I believe all of you have learned in even in the schools itself. And when Mag Mag asked that when you have learned this vector calculus and coordinate systems at last in your schools or in the first year, you have studied anything else about that vectors? Someone can help me, because actually there is no topic available in vector calculus or this coordinate system in your syllabus. Directly they start electrostatics. So should I have to spend time or not? That is the question. All of you know about vectors, vector calculus and all.
Sir, we learned in 12th grade, but not in college.
Okay. So means still, can you recall those all mathematical aspects, how to calculate all vector algebra and vector calculus, like dot product, cross product, all these things? Have you learned about that?
Yes, sir.
Yes,
But not the triple product part.
Okay. So till cross product, I think you people have learned. Correct? And what about the del operator and differentiation in the vector calculus itself? Have you done that? Like taking divergence, curl, like that.
Yes, sir.
Yes,
Yes, sir.
sir.
We have done that.
Is that?
Yes, sir, we did that.
Okay, great. Yes, then I can easily refresh. This class as well as tomorrow's class, I will give some simple ideas about that, not much more in detail or raw or any sort of. So some simple examples I will cover up. then we can maybe that I think the next class will be Thursday. So Thursday we will complete everything about this mathematical aspect. Then we will jump into the core theories, and I'll be really happy about that. So as I already told, the syllabus don't have this vector calculus, all these things. Okay, so this is almost we can say the first class on the electromagnetic field theory. So for now, we have learned only about uh, what are the things that are available in this electromagnetic field theory, what are the opportunities all the way. When we see the electromagnetic field theory, there actually the fields are going to be available in space. They are going to travel in time, or they are going to vary with respect to time or not, which we call actually dynamics or statistics respectively. So particularly the space will come into the picture. So when the space is coming into the picture, we're supposed to regulate the wave which is going in a particular direction or within a particular box or within a particular cylinder or something. So obviously the many shapes will come. So therefore we need proper mathematics for that. So there comes the coordinate systems like rectangular coordinate system, cylindrical and spherical coordinate system. These three coordinate systems are much more enough for this. And then plus time also will come. So there comes space time also will come. You will see some of the equations like continuity equations where space time will come. Very interesting topics. Then so this along with that, all these fields are highly directional oriented, and in fact they vary with respect to time, and they disperse over the time or disperse over the space, spatial dispersion. So many things can happen. So these all things supposed to be done with proper mathematics. For that we need vector calculus, vector algebra and vector calculus is required. So it is very necessary to recall all these things. So that is why this class and next class is dedicated. So if you are comfortable, then it is okay. If you have any doubts regarding that, best you can work out on that. I will give some simple quiz questions at the end of the class. Like I will put it in the Teams itself. In 2 days, you can solve that problem, and you can also work out from your side so that your hands will be very easy for vector calculus. There are some important notations you're supposed to remember. That is what my recommendation all about. So you know about the difference between the vector and scalar. The scalar is going to define the property alone. It may be magnitude or distance or temperature. Most probably it will be coming under the magnitude category. So that is going to carry the information about that. But another very important information about the most of the wave dependent, or wave is always nothing but one which is varying. So in that case, obviously the directional dependency will come. So there comes the vectors. So like we have mass as a scalar and weight will be vector. So the weight vector will be always towards the or always opposite to the gravitational vector. So like that. And then velocity, all these things I believe. So the only difference between them in the books, you can see that they will be defined with the bold letters like that, or sometimes will be defined with this overhead arrow marks, sometimes with like this capped ones. So they are called unit vectors. So that is a major important difference. So you can follow these two any one of the style. So often we will use this unit vector with caps and regular vectors with overhead arrow marks. So you also try to be learning that by the way you won't do any mistakes in the future. Many people simply will put AX, but AX vector like that you have to put in. So that is very important one. And then in electromagnetic field theory, the vector will come everywhere. So whenever you define a point charge or line of charge or a sheet of charge or a magnet or time varying systems like motor, everywhere this vectors will come. So this vectors we have two vectors. One is position vector and displacement vector. So position vector is nothing but a particular point which is keep on varying in a particular direction, let's say. So that is defined with respect to XYZ axis. Uh, at a particular point. Let's say this is the point P, which is at XYZ. Okay. So, and this point vector with respect to the origin, this line joining, we will put an arrow mark that is telling about the direction of the expansion or direction of the change or whatever it is. So that is described by the position vector. So the position is varying. So let's say a charge is keep on moving because of the electric field or magnetic field. So that can be defined by means of this position vector. So the very simplest one is the origin point and the end point. The simple difference between the end point and the origin point is nothing but the vector. So let's say from A to B, system is or a particular charge is moving. So you should know this, let's say A, B, C, and this is E, F, G in terms of then this difference, this E minus A, comma, F minus B, comma, G minus C. So like that actually, so these are defined with commas. So most often this displays, what do you call, the position vectors will be defined by like a point, but the actual meaning is they are actually vectors. So they will be supported by unit vectors, so which we will see much more in detail. And these are nothing but magnitudes of them. And the displacement vector most probably will say the change happens in the vector itself. Like if it is a line vector, then this change in the line, we can call it as a DL. So this DL may have its own projection that will be defined by vectors. So this DL, which is given like a bold letter. So because in the PPT or in the book, it is very often drawing this vector is very difficult, but in hand we can easily do that. So you always do with this hand in this way. So because when you are answering in the exam, when you will write so many things, so many variables will come. So sometimes, many times, A, capital A, small a, like that will come. So you should be clearly defining what is the vector, what is unit vector, what is the magnitude, all the way. So that will come by practice. Okay, so that you have to keep on do that. Even whenever you do a simple calculation, always define that properly. So your hand supposed to be fast enough to finish all these quick things so that you can easily score high marks. Of course, unit vector, it is nothing but telling about the direction or projection of a particular vector. So that easily can be calculated by the vector divided by its magnitude. And the magnitude of the unit vector is always unity. That is why it is called so. And so I believe you know about that. And how to calculate the magnitude, I think you know about that. Square of all the magnitudes, take root of that. So, and here is a simple example how to define a line vector. So if you have a line vector which is supposed to be drawn between this point P and Q, this is point P, point Q, and it is traveling from P to Q. So the easiest one is the difference between the line vectors of Q and P. So this RQ minus RP vector. So it is all defined with respect to origin. So if you know this 2 points, the difference between the 2 points is nothing but this RP vector. So people generally do by means of calculating this vector or simply by differentiating, find the difference between them. So that also one idea. Not difference by subtracting from the end point to the starting point. Here some examples are available. And in case of this geometry, whenever it is coming into the picture, so the higher dimensions may come into the picture, like several dimensions may come into the picture, including time. So those all things were supposed to be included. And whenever you add, you're supposed to add the respective, for example, in X direction only, you have to add two vectors, back components. X components means you have to add, you can't add those Y component and X component. All of that, I hope you already know about that. Then vector multiplication. So vector multiplication is very, very important one. For instance, in a given area, area, once the area is coming into the picture, it will be having a space and it will be having its own vector. Okay, and let's say some electric field is crossing this, and I want to calculate what about the electric field which crossed over that. So I supposed to integrate over this square or rectangle, whatever, and this is the normal vector for that. And let's say this ax vector is the unit vector of this electric field. So when you multiply, you're supposed to do this dot product. So that is defined by this equation. So you are taking the magnitude and multiply with the cos theta, where theta is nothing but the angle between these two vectors. So, and this is very, very useful once. And the dot product always results in magnitude. So you can calculate the total magnitude of the electric field which is crosses that. And then that is often referred to scalar product. And we have other product like cross products. Let's say two products perpendicular to each other, two vectors like let's say electric and magnetic field. In a particular direction, electric field is let's say it is along the x-axis, and along the y-axis we have the magnetic field. So now at this particular point, what is the power? So the power is simply nothing but the integration of E cross H. Since both are perpendicular vector, if you multiply them as a dot product, it is completely meaningless. So these two wave vectors, when you multiply, you're supposed to do with the cross product of that. So, which you know that which will come with sign term. So if two vectors are perpendicular, you will get the maximum power. And so this is possible only along the vectorial directions, and the resulting is always a the normal vector between these two vectors. So when two electric and magnetic field, let's say there is a sheet and yet current is passing through that, then this will create a magnetic field perpendicular to that. And due to some point charge, electric field is coming from this side. So both will interact, will create the power at this particular point. So this is a very, very useful one. And the future will refer this as a pointing vector or something like that. You know about right hand rule, how to apply the this curl or the cross product. So in the vector calculus, we will call the same cross product as a curl and dot product as a divergence, something like that. Coordinate system, I believe you all know about that coordinate system. Three important coordinate systems like rectangle, cylindrical, and spherical coordinate systems. So these coordinate systems supposed to define a particular point clearly without any distinction. So like, and the important aspect of the coordinate system is nothing but the orthogonality. So all these the unit vectors of the coordinate system supposed to be orthogonal to each other. Therefore, this unit vector like ax along the x direction and along the y direction, we're supposed to get 0. So this is supposed to be applicable to all. So this is the very fundamental requirement for the coordinate system. Like that, if you can create some other coordinate system, that will be very, very much possible. Like for instance, how to introduce time dimension into that. So if you see most of the people in gravitational field theory, like for working on black holes, they will be taking this three axes which are perpendicular to each other, and not like this. Let me redraw that. So they will take a circle and they will draw three arrow marks which are nothing but x, y, z, and the time is traveling in this direction. So if when you go through a black hole, how this time will change, all these things like that. So here also you can apply the coordinate system, and according to the general theory of relativity, time is very much behaves like a space. So like how you can bend the space, you can also bend the time. So you can even warp it. So you can make time machines out of that. So definitely it is very much possible like that people are saying, but I don't know what will happen. This three coordinate system will be always accommodated with vector algebra. So any line vector or any particular dimension always defined with this x, y, and z operators, and along with the magnitudes will come. This is a small displacement which is taking place in a particular cubic system with respect to the, so it is simply multiplication of this changes what is happening inside that. And here you can see the magnitudes and directions. And when a box or volume, whenever you try to define, we will always define many things like points and surface and the value. So with respect to that, the vector calculus will vary. I believe you people have learned about that. If you have not learned about that, please comment on the chat box that then I will check out. You can go through the fundamentals. I think you might have downloaded StudyQ book. You can simply go through the first 3 chapters. And then if you have any doubts or questions, if you post it, then we can talk about that, maybe about 5 minutes or something in the class. Like that, we have cylindrical coordinate system. The cylindrical coordinate system is also equally powerful as rectangular or spherical system. So it is, even if you see many of the microwave systems, or in many cases, it is like cylindrical cases, or it will be like a kind of circular tubes or something like that. So where the cylindrical coordinate system is largely applicable. In fact, I would say that a 3 coordinate system will equally contribute. That is why still these 3 systems are always be taught. And this has the radius, height, and the angle will come. These 3 also orthogonal to each other. And you know how to convert this as cylindrical to rectangular to cylindrical, and all these aspects. And I believe you know about that. The radius, they don't have any negative values. So if there is a negative value, it simply tells that opposite direction, not the lesser values or something like that. And then spherical coordinate system. Here also we can define almost any particular point in the system can be defined, and this is one of the most friendly ones when you come to antenna theory. So when you see the antenna books, they always have the spherical coordinate system, since the arrival of the signal or the radiation of a signal from an antenna, it could be in all direction. So that is why it is always used. So the conversion between these 3 coordinate system is very simple ones. They look big, but once you calculated sine theta, cos theta, sine phi, cos phi, you're going to simply multiply and you are going to put the product there. So even though they look very big, they will be very simple only. There are some examples I have listed here. So you can tell me whether I should teach or not. Next, we will go to differential calculus in the next class. Then tomorrow we will discuss about that, because this is also very important ones, where the changes how to define in terms of vectors and coordinate system. That is very, very essential for electromagnetic field theory. So you can go through these all. I will upload these all slides, and you can go through. You can tell me whether I should teach or not, maybe in the class beginning, or if you can tell at least quite some time early, that I will be ready with myself in the class. Can openly tell that. You don't need to hesitate about that. Okay. So I will tell you one important secret about the